Okay, so this is the last lab set that we'll have to deal with when you come into the labs. And the last thing that we'll do will be to set up a DNS server. So we will do this on your main Prometheus virtual machine. And the whole purpose of a DNS server is to basically provide human readable name to IP address translation. Okay, so as we know, the internet works with IP addresses. People work with names. It's much easier to remember www.google.com rather than whatever IP address their DNS server might have. All right, so what we will do in this lab, we will set up a DNS server that will be the fully qualified domain name server for your own domain. So you will all have domains on your computers, which will essentially be the names of your computers, and you will be responsible for them, so that anybody that looks for one of the computers that belongs to you will eventually end up asking your DNS server where they can find that computer, and then they can find it. So I'll give you an example. Anything that ends in port AC UK belongs to the University of Portsmouth. So anybody anywhere in the world, if they ask for find me the, let's try to ping columbus.ae.port.ac.uk, then they will eventually end up querying the university's own DNS server for this information. This works in the way that if you're trying to contact a computer somewhere on the network, then your computer will try to find it in itself. If it cannot, so it will ask what is known as a hosts file. So if your hosts file doesn't know the IP address of the computer that you're looking for, it will try to ask its neighbor. So it will turn the query onto something that is called a resolver, and then that resolver will try to ask the next server up the hierarchy of the DNS domain names that there are. So if, for example, you are inside the University of Portsmouth and you're trying to ping google.com, let's say, for example, that you are in NetLab, then your primary DNS server will be whatever computer we have set up, it's Columbus in this case, as the DNS server. So your computer will ask Columbus if it knows where google.com is. When Columbus says, I don't know, then that request will move on to the next DNS server up the hierarchy into the university itself. So it will go on to the university's main DNS server. So Columbus is responsible that anything that starts with NetLab port AC UK, once they don't know, they will go on to the next DNS server, which is the DNS server responsible for the port AC UK DNS domain. When the University of Portsmouth server doesn't know where it is, so it's not one of its own computers, then it will ask the DNS server on Janet, on the AC UK part, and then when that doesn't know, if it doesn't know, it should know by that point, then that will ask the tier 1 ISP that is responsible for the .uk domain. Once one of them knows where it is, they will direct them, or they will rather get a reply from Google's own DNS server and say, oh yes, that IP address for google.com is 8.8.8.8, and you can ping it there. So all that information will be passed down through all of those DNS servers back onto your primary DNS server and onto your computer, and then you can ping. That's why sometimes there will be the probability that you will try to ping something, especially if it's an obscure address or if it's a domain that's relatively new, and it might take a while to come back with a reply. So the reply might not be instant. Replies are usually instant, especially for the most famous addresses, because DNS servers cache this kind of information. So if Prometheus gets asked, if Columbus gets asked where is google.com and it figures it out that it's at 8.8.8.8, it will cache this information. So the next person in the class that asks for google.com, they will get a reply straight from Prometheus, straight from Columbus, and that will work. I feel like I've complicated this a lot. All right. Anyway, so the point of the DNS server is it knows the names and IP addresses of the computers that you are responsible for, and if it doesn't know, it has the ability to ask its neighboring DNS servers about this information and get this information to the computer that's asking. Okay, so how do we set this up? On our little network that we will have, that looks like this, we will set up the service on Prometheus. Before we do this, you need to make absolutely sure that you have the correct IP addresses from the previous labsit onto your network so that you can ping all of your neighbors. You need to make sure that your routing actually works correctly as well, so that all of your virtual machines can ping the outside world. And then we will need to rename all of your computers. So your computers will be something called Prometheus NetLab Port UK or vPrometheus 012 NetLab Port UK. What we will do in the lab, we will add one more subdomain into this name. So we'll make this ridiculously long name even longer. All right. The part of the name that we will add will be the name of your computer. That's why it says your PC name. So if you're sitting on Alonso, then your Prometheus computer should be called prometheus.alonso.netlab.eu.port.uk. If you're sitting on vPrometheus 2, it should be vPrometheus2.alonso.netlab.eu.port.uk. You need to do this on all of your virtual machines, on all 4 of them, or 5 if you've done the additional test step in the routing labsit. And once you rename them, you will need to restart them as well for the change to take effect, because it is the name of the computer, so you need the reboot for it to work. Once you've renamed it, you need to basically have the service installed that does DNS. The service is called bind in Linux, okay? And to install it, you need yum install bind and bind utils. The -y will automatically say yes to all installation and dependency questions that get asked during the installation, so this will automate this process much more for you. Once you do this, there are some files that you will need to configure. The first and most important file that you will need to configure is the named.conf file. So this is the main DNS or bind configuration file. First job of this file is to tell us which port and which IP addresses to actually listen on. So where will this server actually work? So this server will work on the loopback interface, because they all have to, okay? And it will also work on the publicly known IP address of 148.197.28. Whatever your Prometheus IP address is, okay? I'm working on 50. You will be working on whatever IP address your Prometheus has by this point, which will be whatever your host has plus 50. Once you have this in place, and once you tell the service where the service is actually running, you need to tell it where to allow queries from. So this is a security measure. You can set up your computer so that it accepts queries from anybody around the world, and that's perfectly fine. All right, but because I want you to see how this actually works, I want you to add all of your networks here onto the system. So I want you to have the 4 network addresses that your computers actually connect to. So I want you to have subnet 28, 30, 31, 32. All right, so this will be the networks that exist internally on your computer. There's a mistake in this line. Who can spot it? Yes.
Are we missing 29?
No.
Shouldn't be 2 dots?
No. The numbers. Some of the numbers are wrong. Come on.
The first one was wrong, is it?
What part of it?
148 instead of 192,
Yes.
and 196
Okay.
instead of 168.
So I will fix this on the labsit. I'll correct it as soon as I go back to my office. All right. So it should be 148.197.28.0, because everything in our lab, unless you've done the nothing additional task, everything in the lab should start with 148.197, because that belongs to university. Okay. So subnets 28, 30, 31, and 32 must exist there, and they must have either a 30.0/24 or a 30. Your network address /30. The difference between these two types of configuration is that with the first one, if you do 30.0, it means that you allow anybody on subnet 30, so anybody in the lab, to contact your DNS server. Whereas if you set up your network address here, it means that you're limiting the queries only to the 3 or 4 virtual machines that you have inside your network. Okay, you can do it either way, but if you do it this way with 30.0/24, that means that you can test, and other students in the class can test yours, to see if your server is actually approachable from the outside. Okay, so if somebody is sitting on Alonso and they want to ping vSena2, they should be able to do this. All right, so I recommend that you set them up as .0/24 to allow you to be able to play around with other computers in the network and see if you can contact them. Once you do this, you're still going to be editing named.conf. You need to set up the forwarding zones for your domains. So I'm going to get my face away from here. So you need to make sure that your domain name is set up correctly everywhere. So, your PC name netlab reporters UK, so Alonso netlab reporters UK, for example. And you need to make sure that you also set up the reverse zones and that you set them up for each of the networks that belong to your computer. So to your network, essentially, to your little domain. So again, you'll need the one zone for 28.0, one zone for 30. Whatever your network address is, one zone for 31, one zone for 32. These are reverse zones, so they are written reverse as well. Okay, they thought it would be a cool idea to do it like that, just to signify that it's the reverse lookup. Essentially, if you ping an IP address or if you query an IP address, it should also tell you the name, so the reverse of what the DNS server actually does. All right, so it should work both ways. Once you have that out of the way, then you need to create your zone files. The most important of your zone files will be the file that defines your forward zone. So let's see, this is fun. And let's see if I can zoom into this. Cannot. Okay, so what this file does, it is essentially a glorified hosts file. So this is the one source of information for what IP address corresponds to which name in the computers in your network. Okay, so this file was created for my computer is called Shumi. So my Shumi IP addresses are 28 something, 30 something, and 31 something, because these are the 3 network cards that exist on my computer. So these are the 3 IP addresses that exist on my Prometheus virtual machine, on my Shumi computer. We then have machine 0, 1, 2, and 3. So they can have how many IP addresses you like. As long as you declare them all in this file, then you should be okay. All right, and this helps. So if you have a host that has multiple IP addresses, this also helps because you might have hosts on the inside of the network. So you might be trying to ping vPrometheus 1 from 2. So it will be more direct and easier to actually get a reply back from this IP address. And this especially helps as well if you have some sort of routing problem in the network as well. All right, so that's why we include all of the IP addresses that every host actually has. Once you do this, then you can move on to the rest of the files. You need to create a DB zone file, so you'll have a 148.197.28.db, you have a 148.197.30.db, 31db, 32db, and so on. And they will all need to be in the correct location according to the instructions. Once you have all of the files in place, then you can try to start the DNS server. So you can do systemctl restart named, and you can also do enable named. If it doesn't run, if it comes back with an error, you can do journal ctl -xe, and that will give you in the terminal what went wrong when you try to actually run the service. So it will tell you, you might have a typo in one of the files, you might be missing a semicolon or something or somewhere, you might have some permissions issue, and so on and so forth. So you need to try to troubleshoot it and make it run. You then need to let it through the firewall itself. DNS by default runs on port 53, so you need to let that through the firewall and reload it. And then you need to try and see if your DNS server actually works. So you can try to dig your domain, so www.alonso.net/UK, and see if you get a reply back. The reply you get back from this should be that yes, there is a domain name server for this, and his IP address is whatever the IP address is. If you don't get a reply, it means that your DNS server is not contactable, or is not running correctly, or you haven't allowed your computer to cure it, and so on and so forth. This command should work straight away on the computer that you're sitting on your Prometheus VM, where it is the DNS server, and it should also work from the other computers in your virtual network. Eventually, it should work from any of the computers in the lab as well. Once you have that in place, it means that your DNS server is working. So you should be able to essentially ping the outside world, that's fine, but you should also be able to ping by name all of the computers inside your network. So if you're sitting on Prometheus, you should be able to ping vPrometheus 0, vPrometheus 1, vPrometheus 2, and vPrometheus 3 if you've set it up. Okay. Equally, it means that you should be able to ping from your vPrometheus something virtual machines to the outside world. And if you set up everything correctly, and if you set up the allowed queries to other computers as well, then you can go on to the rest of the computers in the lab, and you can try to ping other computers in the lab itself. All right. Now, there is a bonus round to this one as well, and it says you have all, it's now set up an authoritative server for the same domain on your computers, resolving names like vPrometheus 0 with different IP addresses. Why doesn't this break your network capabilities? Why doesn't it break your internet, at least in the isolated environment that we are in the lab? Okay, so how can you ping computers that have the same prefix, the same name, the first part of the name, without the thing actually breaking? So how does it know where to go? All right, so I need you to explain this to me. If you look at the names, you should be able to figure it out. It's not too tricky. Okay, and that's it. Essentially, it's a relatively easy service to set up. It only has one job to do, figure out names. As long as you tell it in your host file what names correspond to which IP addresses, as long as you allow your named.conf to work correctly on the correct IP address for the server and allow the queries to happen from the correct networks, then there's very little that can actually go wrong. All of the files that you will need for this, all of the example files, all of the DB file, the host file, the name.conf, everything is on Moodle, so you can download them. You just have to be very careful that you need to change names and IP addresses inside all of those files so that they correspond to your own computer every time. Okay, so get examples, put in the correct location, make sure you configure the named.conf file and everything else for your computer names and IP addresses, run it, and that should be it. Okay, any questions about this? All right, so